Welcome to the fascinating world of the brain's chemistry. Today we're diving into the lively dance of neurotransmitters, neurons, and tiny helpers that keep our mind sharp and our mood steady. Let's start with the basics. The heart of neural communication is synaptic excitation, where signals are passed across tiny gaps called synapses, primarily through neurotransmitters like glutamate, the brain's main excitatory messenger. Now, to keep this complex network functioning smoothly, our brain is protected by the blood-brain barrier, a vigilant wall of endothelial cells that prevents unwanted substances like peripheral ammonia from sneaking in and causing trouble. Sometimes if the liver isn't working properly, ammonia can build up, leading to a condition called hyperammonemic encephalopathy, which can include everything from muscle thinking to burnout or toxicity. That glutamine acts as a key player in nitrogen balance, shuttling ammonia safely away from the glutamate cycle. Astrocytes will start to take out the cycle to convert glutamate to maintain a healthy ammonia from neurons. This process involves molecular substyles engaging in energy metabolism like glycolysis and the malate-aspartate cycle to produce the energy needed for neurotransmission. Speaking of neurotransmission, glutamate binds to various receptors, like the ionotropic apakinase receptor, which are liquid ion channels are like the protein G-protein coupled receptors, which trigger a cascade of cellular responses. These responses influence synaptic plasticity, learning, and memory, especially in brain regions like the hippocampus and thalamus, which are sensitive to oxygen levels and can suffer during hypoxia, ischemic stroke, or altitude sickness. But too much glutamate can be a bad thing, leading to excitotoxicity, which damages neurons and can contribute to conditions like stroke or cerebral palsy. That's why the brain tightly regulates glutamatergic activity, balancing excitatory signals with inhibitory mechanisms to prevent chaos. Beyond communication, neurotransmitters like serotonin, dopamine, and other monomers shape our mood, cognition, sleep, and even the simulation of pleasure centers. Serotonin, in particular, is synthesized from tryptophan, beta-catecholamine pathway, which also is metabolites involved in inflammatory responses. Neurotrophins like BDNF and synaptic plasticity plays a crucial role in brain health and diseases like depression. In fact, neuropsychiatric illnesses, treatment-resistant depression may involve dysregulation of monoamines or glutamate signaling. Interestingly, gut-brain axis, influenced by the gut microbiome, impacts brain homeostasis, energy metabolism, and tissue growth. Gut-derived factors can even modulate neuroinflammation through prostaglandins and inflammatory markers affecting long-term potential and hippocampal synaptic plasticity. Scientists are exploring glutamatergic modulating drugs to treat these complex conditions, aiming to restore balance and promote healthy brain function. So next time you think about your mood, memory, or mental clarity, remember the intricate, lively chemistry happening behind the scenes where neurotransmitters, glial cells, and tiny molecular pathways work together to keep your brain vibrant and resilient.